In this video, we're going to talk about example 3.4 from our textbook, standardizing women's heights. So in this example, they say the heights of women aged 20 to 29 are approximately normal with mu equal to 64.3 inches and sigma equals 2.7 inches. So they're giving us all the information that we need to know to be able to do these calculations. We need to, if we're going to be standardizing things, we need to know that it's approximately normally distributed. We can't standardize things from skewed distributions. We also need to know the mean and the standard deviation because those are sort of the landmarks that we're going to use to standardize by. Basically what we're calculating when we're doing a z-score is calculating how far away from the mean, how many standard deviations away from the mean is this particular person's score, or in this case height. And then we can compare those standardized numbers. And so what we're going to do in this case is apply the z-score formula. Now here they filled the formula in a little bit. So we're talking about height. Normally the score would be the data point that you're looking at minus the mean for that data set divided by the standard deviation. So filling that in with the information for this particular example, we're going to look at a particular person's height, subtract from that the mean of 64.3 inches, and divide that by the standard deviation of 2.7 inches. All of our units are going to cancel out here. We have inches minus inches, which equals inches. Inches divided by inches cancel out. A z-score doesn't have any units of measure. So we're going to look at a particular example now. They're going to say a woman's standardized height is the number of standard deviations by which her height differs from the mean height of all young women. So how many standard deviations away from the mean, above or below? So in this case, a woman 70 inches tall, for example, has a standardized height. We'd fill in the value of our data, 70 inches, minus the mean, 64.3 inches, divide that total by 2.7 inches to give us a total of 2.11. Now one thing I do want to note when you're doing this on your calculator, you either need to use two steps here on your calculator or use parentheses. If you were to just type 70 minus 64.3 divided by 2.7, remember, in order of operations, the division would happen before the subtraction. So in that case, if you typed it all in one row with no parentheses, the calculator would first do 64.3 divided by 2.7 and then subtract that from 70, which we don't want. So either do 70 minus 64.3 equals, and then divide that number by 2.7, or if your calculator has parentheses, do parenthesis 70 minus 64.3, close parenthesis, divided by 2.7. So either way you're going to get a 2.11, which means that this person's height is 2.11 standard deviations above the mean. To look at another example, we took a woman 60 inches tall and used that formula. 60 minus 64.3 divided by 2.7 equals negative 1.59. So this means she's actually 1.59 standard deviations lower than the mean height. So by standardizing these heights, we can see that the 60-inch woman is shorter than the 70-inch woman. We can obviously see that just by measuring the 60 inches versus the 70 inches. However, standardizing also gives us information related to how do those two people feel, what are their heights relative to the population. So the 70-inch woman is actually considerably taller than most of the population. She has a positive standard deviation of 2.11, whereas the woman who's 60 inches tall has a negative standard deviation, which tells us that she is shorter than the average person in the population. And her standard deviation is 1.59 below. So she's actually quite a ways away from the mean. So this is one example, not necessarily the most useful example, because when we're standardizing, normally we might do this to standardize and compare perhaps maybe a woman's height to a man's height. because we can't just compare their actual heights together because we want to look at them relative to their population. But this is a good example to show you how those calculations occur and what information you can get from doing this process.